Welcome to Rges Algebra 2. This is lesson 24A, and the sections we will be covering are 7.6 and 7.7. Now, we did go over this fairly well in class this time, but what I'd like to do is do a little review. Let's say if you are taking the square root of 1296, what I want to do is convert that large number to primes. And I think probably the easiest thing for a student is to go ahead and do it by the tree method. I see that a 2 goes into that, and it goes in 6, 4, 8. I see that an 8 goes into that, 81. So now I'll break my 81 down into 9 and 9, into 3 and 3, this is prime, 3 and 3, 2 more primes, 8 is 4 times 2, prime, 4 is 2 times 2, and another 2. So what did I end up with? This ends up being 2 to the 4th times 3 to the 4th, and now this by default, if there's no number as an index, that is a 2, that's a square root. So on my 2's, the exponent is 4. 4 divided by 2 is 2. So that means that you can pull out two groups of 2, or 2 squared to the front. Again, 3 to the 4th, 4 divided by 2 is 2, so that would be that in front. Nothing remains under, because I had even numbers when I divided, nothing remains under the radical sign, and my answer will be 4 times 3 squared is 9, or 36. And I actually taught you more in class than it seems to be covered in your book at this stage. But let's look at the, not too much more, it just doesn't seem like they did anything with leftover radicals. But let's look at the other example. If we had the cubed root of 5832, whoops, let's go to the next line. Let's start again, the cubed root of 5832. I'm going to, again, go ahead and factor that. I'll factor out a 2, and I'll get 18 would be 916, and I'll factor out another 2, and I'll get a 1, 4, 5, 8. I'll factor out another 2. I'll get 7, 2, 9. I'll factor out a 9. I'll get 81. This goes to 3 and 3. This goes to 9 and 9. 3 and 3. 3 and 3. And I like to circle all my primes so that I don't get them lost in all this sea of numbers here. And I will write it out then. That equals the cubed root of 2 cubed and 3 to the 6th. So again, 3 goes into 3 one time, so I'll have 1, 2 out front. We're looking at exponents. 6 divided by 3 is 2 times, so this would be 3 to the 2nd power. We have nothing, no remainders when we're doing our division, so nothing will be left under the radical, and your final answer, go ahead and clean that up. 3 squared is 9, and your final answer, whoops, is, yes, that's right, is 18. Okay. Let's discuss these word problems a little bit more. I'd like you to get very familiar with doing these. It says a truck driver drove 357 miles in 7 hours, part of the time averaging 45 miles per hour and part of the time averaging 55 miles per hour. How many hours did he drive at each rate? So I'm going to let X be the number of hours going 45 miles per hour. And I'm going to let y equal the number of hours going 55 miles per hour. Now I need two equations because I have two variables. So the first equation will deal with the information that altogether it's 7 hours. So that will simply be the hours at 45 miles per hour plus the hours at 55 miles per hour would equal 7 hours. That's equation number one. And equation number two would have to do with the distance we go. If we take the hours at 45 miles per hour and we multiplied it by 45, we would get the number of miles we drove at that distance, at that speed. And if we took the number of hours at 55 and we multiplied it by 55, we would get the number of miles we drove at the second speed, and altogether we drove 357 miles. So these would be my two equations. Now you could either solve by substitution or solve by linear composition. Let's look at some more. Number 8, again on the same page, 18. It says, a pier jutted into the water a distance that was 70 feet less than the length of the part on land, and 2/3 of the total length was 190 feet more than that of the part over the water. Find the total length of the pier. So it seems like we're talking about two different things. We're talking about the part over the land, and we're talking about the part over the water. So I'll let L equals the distance of the pier over the land. And I'm hoping you're seeing that now that we have the ability to write two equations and solve them, this just becomes so much simpler. And W equals the distance of the pier over the water. Now we need two equations. Why don't you put it on pause for a second and see what you could do with your equations before you come back and look at mine. Okay, so these should be your two equations. Let's look at them very quickly, reading straight off the language of the word problem. A pier jutted into the water a distance that was 70 feet. So the water part was, any form of the verb to be is going to be an equal sign, was 70 feet less. That means we need to subtract 70 from whatever else there is from the length of the part on land, and that would be the L. For the second one, and 2/3 of, the word of would always indicates multiplication of the total length. What would the total length be? It would be the part over the land plus the part over the water was, there's my equal sign again, 190 feet more. That means I've got to add 190 feet to whatever else I have, more than the part over the water. And that reads out pretty clearly, hopefully. And then they ask you, so you'll solve for W and L, but notice the question. It says, find the total length of the pier. So we'll have to add them together to get our final answer. Now this would be, because of this first equation, this is very conducive to solving by substitution. Let's look at your next problem. What I want you to do is put it on pause right now, identify your two variables, write them out by their definitions so you don't get lost. You can always refer back to those as you're now writing your two equations. Then write your two equations and then unpause it and see if you're thinking like I'm thinking before you go ahead and solve them. So my first equation should be this one, my second to be this. They're going to be solved simultaneously, or are all these others. And let's make sure that you see how I did that. I have two tanks, and the question is, how many gallons did each tank hold? So I know that they're not the same size. So the first tank will be X, the size of the second tank will be Y. Two tanks together, two tanks held is equal to, contains 550 gallons of water. If one, there's the first one, held 75 more, that would be adding 75. And the other, there's my second tank, held 125 less, so I would have to subtract 125, then they would be equal. Now, how would I solve this problem, this one here? A little bit different. Well, if you want to, I think I'd be inclined to go ahead and solve it by linear combination. You could solve it by substitution, whichever one you prefer. But if I'm going to solve this by linear substitution, for this one, I'll need to take my y to the left and my 75 to the right. So that would be minus 200. And we're going to add straight down. These will eliminate. And this would be 330. So you go ahead and continue. Let's see if I make sure I did that right. Okay. I almost did it right. That bothered me a little bit, and the reason why is this here. Just try that again. 550 minus 200 is 350. There we go. So you can finish those out, and we'll check your answers when you get to class. But I just want to continue to illustrate how we find our equations till this becomes very comfortable to you. Now, in the last section, 7.7, I told you to do a few things on the calculator, and that would be I think all of those, 1, 5, 9, 13. Go ahead and just do those on the calculator. Also 17. And I just want you to make sure you're comfortable with your calculator and can find your way around it doing these roots. Okay. Now I do want to look, however, a little bit down below on the Pythagorean Theorem. Okay. I blew through that very quickly in class. One more time to review, but the Pythagorean theorem is based on a right triangle. And if you recall, the hypotenuse is always the longest side, which would be opposite the right angle. So this would be A, this would be B, and C represents our longest side. And the Pythagorean theorem says that for every right triangle, C, or the hypotenuse, equals the square root of a squared plus b squared. Okay. Or we could think c squared equals a squared plus b squared. Either way. But if we're finding c, we'll use this one. And we reviewed that when we were doing distance, if you recall. Now, so he says in number 23, if a is 44 and b is 33, what would c equal? So we would just use this formula right here. We'd have to square those larger numbers, and then we would take the square root. And that looks like a great calculator problem to me. So don't be afraid of the calculator. Now, if for 24, it says if C equals and B equals, so don't forget you're going to plug in that one and solve for A. Now, if we're doing something like that, let's make sure we know how to do that. Okay, so C is 30 equals the square root of a squared plus 18 squared. So what would I do? I would square my 18, and then to get rid of this square root sign, I would have to square both sides. If you square a square root, you'd be left with a squared plus whatever 18 squared equals, and then you would have to square that side too. So to get rid of the square root on the right side, I would end up squaring this side. Okay, and then the rest of it you can solve. Okay, go ahead and try to do the rest of those on your own, and we will talk about them as we need to when you come to class. Now, the last thing I would like to do is look at those two-word problems, 29 through 30. Again, doing just the equation part together, and then I'll let you figure the rest out yourself. So go ahead and put it on pause and attempt to get your equations for 29. Now it says we're going to separate a number into 3 parts, so I'm going to expect 3 equations. Okay, right before I left you, I said I think 3 equations. What I really meant was 3 variables. So go ahead and identify your variables, write their little definitions there, and then now let's read the information. We're going to separate 800 into 3 parts. Okay, such that the sum of the first, 1/2 of the second, and 2/5 of the third is there's my equal sign, 400, and the sum of the second, 3/4 of the first, and 1/4 of the third is 400. Okay. So very, very clear how that reads right off the English. Now, to solve that, of course, I would need to put my x's and y's in proper order. You might just want to go ahead and get rid of fractions by multiplying everything in the first equation by 10, knocking out those fractions, and everything in the second equation by 4. Knocking out those fractions, and then you're going to, of course, eliminate one variable, then plug in to, so that then, let's say you eliminated x's, I don't know what you'll choose to eliminate, and then the x's will be gone, you'll have y's and z's, solve for y, eliminate all y, solve for z, then plug it back in to solve for the y, then plug them both back in to solve for the x, reviewing, of course, what you did when you did 3 variables. Now, if you have any questions working that out, okay, in fact, I'm going to just give you the answers, actually, to that one, and you see if you can get these answers. X is 100, y is 200, and z is 300. So 500. So work it out. Altogether, they equal 800, and that certainly does. Go ahead and do the problem. This is good practice for you. See if you can't get these answers, and only if you cannot, when you come to class, let's talk about it some more. Now, the last one is number 30. It's 3 different size jars. Okay, so you go ahead and I'm going to take S equals small jar, M equals the medium jar, and L equals the large jar. Okay, so now you go ahead and see if you can get the equations. Put it on pause and then come back to check yourself. I think this one's a little bit trickier, and the trick to these equations, of course, the relationship, it's